Okay, hello everybody. We've spent the last couple sections talking about surface area of some three-dimensional figures. Now we're going to switch over to volume today. Section 12.4, we're going to talk about the volume of prisms and cylinders, those two types of shapes. All right, now remember, surface area was square units because it was the total area of all the surfaces, flat surfaces. Volume refers to the amount of space, three-dimensional space on the inside of the shape. So volume is going to be cubic units. So for given units, make sure we go ahead and in our answer, label our answers as, say, inches cubed or centimeters cubed, etc. Okay? So cubic units or units cubed for volume. There is a generic formula for volume for the two shapes today, prisms and cylinders, and it's right here. Now, most people like volume better than surface area because, first of all, the formulas are shorter, which generally makes finding volume a tad bit easier than finding surface area. If we look at the formula, you'll see that it's simply volume equals capital B times H, area of the base, just like it stood for in surface area, times H, which is the height of the prism. So capital B is area of the base. So on the side, you have to figure out what the area of the base is, depending on the shape of the base. Square or rectangle, maybe a triangle. Sometimes they will give you the area of the base and you just plug that right in for B. Sometimes you have to figure it out though. And then H is the height of the prism. Okay, this is not the slant height. This is the straight perpendicular height between the bases. It's not always up and down. It could be going side to side possibly. Just remember that the height goes from base to base. Okay? Now, you're going to use this for all prisms and cylinders. So whether it's a rectangular or triangular prism, the two most common types of prisms, or whether it's a cylinder, we're going to use a different pen because this one seems to not want to write. We're going to use the same formula. V equals BH. 1 second, everybody. Let me grab another pen. All right, so for all prisms and cylinders, capital B times H. Okay? Now, one last thing before we do some examples and apply the formula. Sometimes you have shapes, three-dimensional shapes that are oblique. Okay? All oblique simply means about the shape is that it is not standing straight up and down. The height, or rather the sides or lateral area, isn't perpendicular to the bases. It basically means that it's leaning. It's a shape that's leaning. Like, for example, just a quick sketch. Most cylinders kind of might look like this. Well, an oblique cylinder might look maybe something like this. Okay, so maybe a regular, what they call a right cylinder versus an oblique cylinder. Okay, now the main thing about oblique is that the height isn't going up and down the side. Like for this cylinder here, it's a right cylinder. So the height would be between the circular bases. But for an oblique shape, okay, this is not the height because the height has to be perpendicular to the base, okay? So the height for an oblique usually is like an imaginary height on the outside. So it would make a right angle with the imaginary extended base, okay? So that's what oblique means. Now, you're not going to change the formula, though, for an oblique shape. You're going to use the same volume equals capital B times H formula, okay? So the good thing about an oblique shape is that you use the same formula, okay? And don't forget that the height is usually an imaginary height, because it does have to be perpendicular with the base or ground or bottom or imaginary extended height, imaginary extended base. All right, so that's what oblique means. All right, let's go ahead and hop to the back and do some problems. All right, here we go. Number one, we're going to find the volume. We have a triangular prism. So we're going to bring up the volume formula. All right, well, the height of this is between the triangular bases. The height is 10. We do have to calculate the area of the base. Now, the base is a triangle, so we're going to do 1/2 base times height, because it is a triangular base, and that's the area of a triangle. Now, look at the triangle. You've got 5, which is the same as that 5, and this is 13. That's the same as this 13. You're not given this side. If we look at the formula, we need to multiply the base and height together, take half of it. Well, remember, in a triangle, the base and height form the 90-degree angle. Since this is a right triangle, your base and height are these two sides, and we don't know that side. You're not going to multiply 5 and 13 to get the area of the triangle, because that is not the base and height. Those do not form the right angle. It's these two sides. So we have to solve for this side. How do you think we're going to do it? Right, Pythagorean theorem. So sometimes, guys, if you have a triangular prism, you might have to not only find the area of the base on the side, but do Pythagorean theorem to get one of those sides of the triangle in order to get the area of the base. All right, so some of y'all might notice that 513, that is a common Pythagorean triple. If you solve use the Pythagorean theorem, or if you recognize the missing number from the triple, it's going to be 12. So Pythagorean theorem, that side is 12. All right, so over here, area of the base, we can do 1/2, 5 times 12. That will give us 30 for capital B. Now we can easily just plug that in for capital B into our volume formula. And the height we saw was 10 earlier. And simply multiply 30 times 10 to get 300 for the volume of that triangular prism. And we attach our unit, cubic inches or inches cubed. And there we go. Number one, volume of the triangular prism. All right, let's look at number two. Number two, we have just a basic cylinder. So we bring up the volume formula. Capital B times H. The height goes from base to base, so that would be 8. We do have to solve for the area of the base. It is the area of the circle. And a circle, remember, is pi r squared. Radius being 3. 3 squared is 9. So the area of the base is 9 pi. So we have what we need. We can put 9 pi in for capital B. And we simply multiply the numbers and keep the pi onto it. 9 times 8 is 72. And you can keep your pi for an exact answer, or if you want to multiply it out and round it, you can. And don't forget to attach your unit, cubic centimeters or centimeters cubed. And there's your volume for number two, the cylinder. Okay? All right, moving right along. Here we go. Number three. Now, number three, it says we have an oblique pentagonal prism with a height of 24 and a base area of 120. Okay? Now that should be square millimeters. I just forgot to put it. All right, so again, same volume formula. Because remember, oblique means leaning, but you don't change the formula. So let's bring up our formula, see what we got. Now it gives us the height 24. We can put that in for H. And we don't have to do any work on the side to get capital B. It would probably be a pain in the butt anyway because it's a pentagon shaped base. Luckily, it gives us the area of the base. So we can put that right in. So it's just 120 times 24, which is B times H to get the volume of that oblique pentagonal prism. And you end up getting 2,880 millimeters cubed for number 3. All right, here we go. Number 4. Number 4. A cylinder has a volume of 1,000 cubic inches. If the diameter is 14 inches, what is the height? Okay, so it gives us the volume. We're going to have to work backwards here and get the height. So we're solving for H. All right, well, let's bring up the formula. All right, plug in what we know. We know V the volume. We can put 1,000 in. Capital B we don't have. And we're solving for H. So we're going to have to, on the side, compute capital B. And since it's a cylinder, it would be pi r squared for the area of the base. So let's get to it. Pi r squared, the radius is going to be 7 because it gives you a diameter of 14. So r is 7. So 7 squared 49 times pi. Let's just there's no pi over here to cancel out the pi on the right when we put it in. So I guess if we want, we can go ahead and multiply to get a decimal here. If we do 49 times 3.14, we get 153.86 or 153.86. So we can put that in for capital B. And now you'll see that all we have to simply do to get H is divide both sides by 153.86 to cancel it out. And if we punch that out, 1,000 divided by 153.86, we end up with rounding to the nearest tenth right at about 6.5. And it looks like our unit is inches. So 6.5 or 6.5 inches would be the height. All right, so you'll get some problems where you have to work backwards possibly, but you still use the same formula. All right, let's look at number 5. Okay, number 5 says describe how each dimension change affects the volume change. All right, we have parts A, B, and C. Now we're talking about a cylinder. So let's bring up the volume of a cylinder. Volume equals BH. Now it says the height is double. Part A, only the height is double. So the height is multiplied by 2. If that's all you're doing, then that is going to multiply everything over here by 2. So the volume would also be doubled. So in a cylinder, if all you do is change the height, the volume also gets changed by that amount. All right, so the volume change means that the volume also doubles or multiplied by 2 for part A. Okay? Now, part B tells you what happens if the radius is quadrupled. Well, there's no R in this formula. But if we look at what capital B is pi r squared, the area of the base. So if we change this formula a little bit, instead of capital B, put pi r squared, because that is the area of the base. See what we're doing? Capital B, pi r squared. And then h, we're going to keep h. So now our formula looks like this. Instead of capital B, it's pi r squared, still times h. Now, the radius is quadrupled, which is what? Times by 4, right? Well, if you look at your formula, it's not just a normal r, like there was a normal h. You're squaring the radius. So whatever you do, whatever change you make to the radius, you have to square that change or square that factor. So since it's a times 4 factor for the radius, you have to square that times 4. 4 squared is what? 16. So if you quadruple or multiply the radius by 4, it's going to actually change the volume by a factor of 16. So the volume really gets multiplied by 16 times the amount. Because since you're squaring the radius in the formula, you square that times 4 amount. And let's try one more, part C. Last part for number 5. Again, we're going to use pi r squared h because in part C, we're doing two things now. 1 to the radius, tripling it, times by 3. And 1 to the height, we're doubling it, times by 2. Well, the height is just a normal h, so that's a times 2 factor for the volume. We just saw in part B that you have to square the radius factor. Well, that's being tripled times by 3, so we square that. Now look what happens. If you triple the radius, you really increase the volume by 9, because 3 squared is 9. So that's a times 9 factor. And the height is a times 2 factor. If you multiply the times 9 factor and the times 2 factor together, what do you get? 18. So both of these will multiply the volume by 18. So volume for part C times 18. If you triple the radius and double the height. Okay, so that's how you can tell what happens to the volume if you make certain changes to the height or the radius for like a cylinder, say. Okay? All right, one last thing, guys. Check out this homework hint I gave you. On number 22, it looks a little bit tricky. All you really need to do on 22, go ahead and read the problem. Make sure you understand what's going on. All you really have to do on 22 is they give you 2 dimensions or 2 numbers. They give you 10 for one dimension, or maybe the volume or something, and they give you 2 for something else. Go ahead and substitute. Put the 10 and the 2 values into the cylinder formula. And then you're going to work backwards and solve for the radius. And then after you get the radius, you can simply double it to get the diameter. Okay, so on number 22, try these steps if you don't really understand how to do it. And that is it for 12.4, guys. Volume of prisms and cylinders. Talk to you later. Have a good day.